Good morning, everybody. Welcome to Unacademy. Today we will going to see our next lecture on discrete mathematics. That is third lecture. Welcome to Unacademy. So today we will going to see our third lecture on the discrete mathematics. In this lecture we will see the normal forms. In last lecture we have seen already the all the conditional forms. Okay, biconditional, everything, logical equivalence that we have seen already in the last lecture. Today we will going to see our uh, normal form in this lecture, which is how to calculate the normal form without using truth table and with using truth table, that I will discuss in this lecture. And also the logic quantifiers, that is existential quantifiers and universal quantifier, that we will see in this lecture. Okay, before going to start this, let me introduce myself. Myself, Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University, also having 13 plus years of teaching experience, and I also mentored more than 10,000 plus students for the engineering. Okay. Now we'll start our actual topic here. Here I will tell you how to install the Unacademy's Learning app. First, go to your mobile's Play Store app, then search Unacademy's Learning app, then install the Unacademy's Learning app. आफ्टर दैट यू हैव टू मैनेज योर गोल हियर. जैसे कि हम लोग यहाँ पे हम लोग अभी गेट एंड ईएसई के लिए पढ़ रहे हैं, सो यू कैन मैनेज योर गोल हियर गेट एंड ईएसई एंड देन टेक द एनी सब्सक्रिप्शन प्लान, either plus subscription, free courses, special classes that you want, and then press the button get subscription. And if you want 10% discount on your subscription fees, then you can use my promo code DSP to get the 10% discount on it. And you can pay your subscription fees by using any one of this method as we have listed here. Okay. Now next is to unlock the Unacademy's free plan. You can use my promo code DSP. In that free plan includes the special classes, live test series, quiz, and Unacademy Combat. Now let's start our actual topic, that is normal form. Okay, what do you mean by normal form? There are actually 4 types of normal form, but in this lecture we will see only the 2 normal forms. Whenever the logic with the help of truth table, we compare if 2 statements are equivalent, but when more statements are proposition and involved, then this method is not practical. Okay, when we compare, when we have to compare 2 or more statements, either it is equivalent or not, but when the statement contains more than 2 statements, then it is not practically possible to check whether the given statement is equivalent or not. Okay, so at that time we will use the normal forms, and there are 2 types of normal forms. First is conjunctive normal form and second is disjunctive normal form. Okay, so first we will see here conjunctive normal form. What do you mean by conjunctive normal form? Conjunctive normal form is a conjunction of, as we have seen, what do you mean by conjunction? So conjunction normal form is a conjunction of fundamental disjunctions. Okay, now fundamental disjunctions are disjunctions of simple statement. It is joining 2 statements by or. Okay, so it means in a small bracket we can write here conjunction, fundamental disjunction, and conjunction like this. It means 2 or more statements are combined with this or, and all these statements are combined with and. So this is conjunction. So conjunctive normal form is a conjunction of fundamental disjunctions. So these are the fundamental disjunctions. Suppose this like this. Okay, these are the fundamental disjunction. So joining 2 or more statements by disjunctions, and these statements are joined by, it means small bracket contains or, and between these 2 brackets contains and. So this is conjunctive normal form. This is for example. This is example of conjunctive normal form. Okay, it means now fundamental disjunction. Conjunctive normal form is a conjunction of fundamental disjunction. These are the fundamental disjunctions. Okay, in a small bracket contains. In a small bracket contains here or, and between these 2 bracket contains and. So this is fundamental conjunction of a fundamental disjunction. This is your conjunctive normal form. Okay, now what do you mean by disjunctive normal form? Disjunctive normal form is a disjunction of fundamental conjunction, exactly opposite. So disjunctive normal form is a disjunction of fundamental conjunctions. Now fundamental conjunctions are conjunctions of simple statements, that is joining two statements by and. That is P and Q, negation of P and Q, negation of P and negation of Q, P and negation of P, or Q and negation of Q, negation of P are fundamental conjunctions. Hence, disjunction of a fundamental conjunctions are joining fundamental conjunctions by or. For example, here disjunctive normal form is like this. So, negation of P and Q, or P or Q, P and Q, or P and negation of Q. This type of form is called as the DNF, disjunctive normal form, disjunction of fundamental conjunctions. Clear? Matlab, in small bracket, you have to join these two statements by and these brackets are joined by or. So this is disjunction of fundamental conjunctions. Okay. Now we will see the normal forms. Obtain the conjunctive normal form here for the given statement. Negation of P or R and P implies, negation of P implies R and P implies Q. First one we will see. So we have to convert it into conjunctive normal form. Conjunctive normal form, it means we have to convert given bracket in this form. Okay. Ultimately, you have to convert this form into this. Okay. So as we know that in the last lecture, we have seen the equivalence of two statements. What do you mean by equivalence of two statements? Here P implies Q is equivalent to negation of P or Q. So in disjunct CNF, we required fundamental conjunction of fundamental disjunction. So for that, we have to convert this implication or conditional statement in either or and. Right. So for that we will use the here equivalent statement, that is P implies Q is equivalent to negation of P or Q. As we have seen in the last lecture how these statements are equivalent by using your truth table. Okay, these two statements are equivalent by using truth table, we have seen. Now here P implies Q is equivalent to negation of P or Q. So instead of negation of P implies R, we can write negation of P or Q, right? So here negation of P or Q, it means P implies Q, we can write here negation of P or R. Right, these statements we have written here. If you want, you can write it here. See, negation of P implies R and P implies Q is equal to this, and negation of P or Q. Right, P implies Q, it means negation of P or Q. Since here we know that as P implies Q is equivalent to negation of P or Q. Right, we have used this statement P implies Q is equivalent to negation of P or Q. Now here negation of P is P or R. Here negation of P is P or R and negation of P or Q. Right, this is simple CNF. As we have seen, this is disjunction of fundamental conjunctions. We have converted into disjunction of fundamental conjunctions. This is your CNF, conjunction of conjunctive normal form, conjunction of fundamental disjunction. It's a very simple form. This is first example. See here once again, negation of P implies R and P implies Q. Right, so negation of P implies R, we can use this P implies Q, it means negation of P or Q. So will this negation of P or implies Q, so negation of P or R. Right, so negation of P or R and a negation of P or Q. So negation of P is P or R as it is, and negation of P or Q. So this is disjunction of conjunction of fundamental disjunction. So this is your CNF form. Okay. Now we'll see the second one. Here second one is given P and Q or negation of P and Q and R. Negation of P and Q and R. So we have to convert it into CNF form. It means conjunction of fundamental disjunctions. Okay, it means small bracket we have to write the disjunctions, and these disjunctions are joined by conjunctions. Okay, now P and Q. So which law we will use? We will use here left distribution law. Left distributive law that we have seen already in the last lecture, previous lecture. So which is equivalent to, here P and Q, we can write P or, see here how I distributed this, P or negation of P and Q and R. Okay, I distributed this. The A and B or C is here A and B, A and C, or B, see here, A or C, sorry, here A or C and B or C. So we'll use this distributive law. So left distributive law, P or negation of, so this is P or negation of P and Q or and R, or we can write here and here you will get Q or negation of P and Q and R. Are you getting it here? P or negation of P and Q and R, and Q or negation of P and Q and R. Right? So which is equivalent to, again here use P or negation of P and this and P or Q, and again this and P or R. Are you getting it up to this step? P or negation of P and P or Q and P or R, and Q or negation of P and Q or Q and Q or R. Okay, now which is equivalent to P or negation of P is always, if P is true then negation of P is false, and if P is false then negation of Q is true. So the statement is always true, truth value of this statement is always true, so it is true. True and P or Q, right, and P or R and Q or negation of P and Q or R is always Q, right, is always Q, and Q or R, there is Q or R. So which is nothing but here true T and this. So totally value is depending upon and of these two statements. So always it is whenever P and Q is equal to true, whenever P or Q is equal to true here. Right? So it is value, this value is totally depending upon P or Q because it is true. So this value is totally depending upon P or Q. If P or Q is equal to true, then T and T is also true. If P or Q is equal to false, then T and false is equal to false. It means this value is depending upon P or Q and P or R and Q or negation of P and Q and Q or R. This is here. Now see here, all the fundamental conjunctions are fundamental disjunctions are joined by and. So this is your CNF. This is conjunction of fundamental disjunctions. So this is your CNF form, right? conjunctive normal form of the given statements. Okay, I repeat the statement again here. See, P and Q or negation of P and Q and R. So will distributive law, we will use here distributive law. Which law we will applicable here? Which laws is applicable? So suppose here A and B or C, then we will use here A or C and B or C. This type of law, left distributive law, we will use here. So exactly similar way, suppose this is your A, this is or B, A and B or C. So you can write here A or C and B or C, right? A or B and B or C. So here P or negation of P and Q and R, and Q or negation of P and Q and R, right? So P or negation of P, again here distributive law we will use P or negation of P and P or Q and P or R and Q or negation of P and Q or Q and Q or R, right? Now here P or negation of P is always true. If P is true, then negation of P is false, and if any one of them is true in our statement, if any one of them is true, then it is true. Okay, only that is false when both are false, right? But here both, if P is true, then negation of P is false. If P is false, then negation of P is true. So anyway here at least one times the statement is true. So whenever it is true, one of them is true, then always the truth value of the statement is true, right? So here you will get true, and P or Q and P or R and Q or negation of P and Q or R. So P or Q and P or R and Q or negation of P and Q and Q or R. This is your conjunction normal form. Okay, this is called as conjunctive normal form for the given statement. I hope you are getting it clear. Now we move further. See, obtain the disjunctive normal form of. So we will see the disjunctive normal form. It means disjunctive normal form. It means ultimately we have to write it here. Disjunction of fundamental conjunctions. It means in a small bracket there is and between these two brackets there is or, right? Disjunction of fundamental conjunctions. So again here we will use the rule P implies Q. So what do you mean by P implies Q here? Which is equivalent to first P implies Q and negation of P and Q. As we know that P implies Q is equal to negation of P or Q and negation of P and Q, right? So negation of P and Q. So here again we will using distributive law. So which distributive law we will use here? See, negation of P and negation of P and Q, or Q and negation of P and Q. Again using distributive law, negation of P and negation of P and Q, or see here negation of P and negation of P and Q, or Q and negation of P and Q, right? So again we will use it here. So negation of P and negation of P, right? There is negation of P and negation of P and Q, or Q and negation of P and Q, right? So here if you observe, negation of P and negation of P is same as negation of P, whatever the value will be there. P, negation of P and negation of P is always again negation of P, and this is and Q, so we can take it in this bracket, or Q and negation of P and Q. As we know that by using associativity here, associative law or associative and commutative laws, we will get Q and negation of Q, negation of P and Q. Q and Q is always Q, So Q and negation of P. Now if you observe, see here disjunction of fundamental conjunctions. In small bracket, these two statements joined by and these two brackets joined by or. So this is your DNF. Are you getting it? The disjunction of fundamental conjunctions by using here associativity and commutative law, associative and commutative law, associative and commutative law here we can use, and here we'll use the distributive law. If you want, here write down distributive law. And here, as we know that since P implies Q is equivalent to negation of P or Q, that law here we are already used. Negation of P implies Q is equivalent to negation of P or Q. Okay, so this is your disjunctive normal form for the first statement. Now we will go to the second statement. The second example here, negation of P, not P and P implies Q, P and P implies Q implies Q implies Q. Okay, so first our job is very simple statement here, which is equivalent to P and. First we will convert this conditional statement into and or. So P implies Q is equivalent to negation of P or Q implies Q. Again, what we will do here, this is your P and this is your Q. So P implies Q. It means you will get a negation of P and negation of P or Q or Q. Okay, are you getting it? Again, equivalent statement here, since P implies Q is equivalent to negation of P or Q. Here is also same reason. P implies Q is equivalent to negation of P or Q. Right? So negation, which is equivalent to negation of P and negation of P or Q or Q. Right? So distribute this negation sign. So negation of P, negation of and is or, negation of P or Q or Q. Right? So here negation of P or negation of P is P, and negation of and or is and, negation of Q or Q. Now if you observe, this is disjunction of fundamental conjunctions. Okay, so this is your DNF. I hope you are getting it clear how to write down the DNF and CNF for the given statement. Okay, now this is without using truth table. Now these normal forms we have find out by without using truth table. Now we'll see how to find out the normal forms with the help of truth table. Okay. Now see, find the DNF of P implies Q and R and the negation of P and negation of P implies negation of P and negation of R by truth table method. So first of all, we will calculate the truth table here. Okay, then we will see how to find out the DNF. So for PQR, so here is PQR. PQR, we required negation of P also. Then we required Q and R. Q and R. Okay. Then we required negation of P. First P implies Q and R. Okay. Then we required negation of P and negation of R, negation of R. Okay, then negation of P implies negation of. So what I will do, this is A, this is B. Okay, so negation of P implies negation, sorry, here is B. Negation of, so A implies B. Instead of writing whole statement, I'm writing this as it is. Okay, A implies B. A, it means negation of P implies negation of P and negation of R. So A implies B here. Now we'll require these things totally. So this is your, suppose C. P implies Q and R. Suppose this is C. And this is your D. A implies B, it means D. So we can write here C and D. Are you getting it? Instead of writing whole statement, I'm creating like this P, Q, R. This negation of P, it means A. Negation of, here A implies B, it means negation of P implies negation of P and negation of R. Right? And this is your D. So this is your P implies Q implies R, it means C, Q and R. So C and D. Okay, so we will find out here. There are three statements. So truth table is T, 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 F, 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 F. Okay, here is F. Now T, F, here is T, F, T, F, T, F, T, F. Okay, now R is, sorry, here is TT, two statements. TTFF, TTFF. Here is TF, 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 TF. Now negation of P. False, 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 false. True, 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 true. Right? Then Q and R. So Q and R both are true, true, false, 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 true, false, false, false. Okay. So Q, P implies Q and R. So P implies Q and R. This statement is false only when the second statement is false. So T, 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 F, F, T, F, F, T, F, 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 T, T, F, F, T, F, F, T, F, F, T. Right? Now next is P. We can write negation of P and negation of R. Yes, we require negation of R also. So for that, first of all, we will calculate negation of R. I am creating here only. So negation of R. So FT, 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 FT. Right? This is your negation of R. Now negation of P and negation of R. Negation of P and negation of R. FFF, FTF, FFF, FTF, TFF, TTT, TFF, TTT. This is your negation of P and negation of R. And A implies B. A implies B, FFT, FFT. Right? Here is also T. A implies B. So here again FF, T, TF, F. Right? Then again TF, F. Here is T and T. Right? Now C and D. First we'll calculate C and D. T, T, T. F, T, F. F, T, F. F, T, F. F, T, F, F. T, F, F. T, 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 T. Okay. Now, how to find out DNF by using this truth table. अब यहाँ पे क्या करना है आपको, ट्रूथ टेबल में जो लास्ट स्टेटमेंट है, मतलब ये हमने पूरी इसकी ट्रूथ वैल्यू जो निकाली है, ट्रूथ टेबल C and D, it means this is whole statement you are. Now, this is your whole statement. T and C and D it means. Now see the truth table of this. Now where it appears T first, so T is your first, right? Now see the corresponding, I'm writing here DNF here only, okay? See the corresponding truth value with the next one. See the corresponding truth value here. So T है यहाँ पे, right? So T से corresponding जो भी PQR की values है, वो हम लोग लिखेंगे यहाँ पे P, right? True है, it means यहाँ पे भी true होगा, right? Here is also true. Now you will get no P, right? First true value is here T. So DNF, disjunction of fundamental conjunctions. So P and Q and R. This is your T first. Then this T is denoted by, now this T, again check the next T here. Now which is the next T? So next T is here. Now join this by OR and write down the corresponding values. Now here is F. So F it means here negation of P. Here is F again. So here negation of and negation of Q. And here is T. So here is R. Right? OR. Now the next T. So corresponding values of PQR, FFF. It means here is, you can write negation of P and negation of Q and negation of R. This is your DNF with using truth table method. Okay. So see again here, we can write P and Q and R, or negation of P and Q and negation of R, or negation of P and negation of Q and negation of R, right? So this is your truth CNF by using truth table. I'm sorry, DNF by using truth table. Okay. So we'll see the corresponding truth values and write down the corresponding values of PQR and combine these two values with the help of AND. And again, this small next T you can join with OR and the corresponding truth values. Again T, right? Here negation of P and Q and R. Here is negation of Q. Negation of Q and R. Okay, so this is your DNF with the help of truth table. Okay, now as we know how to find out the truth table by using truth values. Now next is find the DNF of, अब यहाँ पे DNF तो निकाल दिया हमने, find the CNF using truth table method. Okay, DNF निकालना आ गया, अभी CNF निकालते हैं. Okay, हम लोग और एक एग्जांपल भी लेते हैं इसका. CNF निकालने के लिए फर्स्ट find out the truth table. P, Q, only two statements are there. Okay, so PQ, P and Q. Here is Q implies P. Here is P and Q implies P. Okay, so here T T, F F, T F, T F, P and Q. If both are true, then true. One of them is true, then false. False, false. Right? Q implies P. T T, T. F T, T. T F, F. F F, T. P and Q implies P. T T, T. F T, F. F F, F. T F T, F. Now here CNF is equal to CNF. If you want to calculate, then CNF is, here we can write P implies Q. P and Q here. CNF, it means conjunction of fundamental disjunction. So here CNF is conjunction of fundamental disjunctions. We can write here, see, corresponding, see the truth value which is false. While find out the CNF with the help of truth table, see the first F. Okay, here first F is here, and write down the corresponding values. Now here is false, so here is negation of P, right? We can write here negation of P, or, okay, here, or the next value is, here is F, so Q as it is, right? Negation of P or Q, and here the next value of F is this, so P as it is, true है, तो यहाँ पे और negation of Q, right? The next F is FF, both are FF, so and here is P or Q. This is your CNF with the help of truth table. Are you getting it? So see the first F false value, whatever your statement is given, see the truth table of that, and the last statements of F, it contains F. यहाँ पे F आ रहा है, तो F के corresponding P and Q की value देखनी है. अगर F ही है तो Q as it is होगा. अगर वो true आ रहा है तो वो negation of होगा, because यहाँ पे false है. राइट, डीएनएफ में क्या करते हैं, अगर टी है तो करस्पॉन्डिंग, अगर वहां पे एफ है तो उसका नेगेशन लिखते हैं. यहाँ पे उल्टा, अगर यहाँ पे टी है तो उसका नेगेशन लिखेंगे. राइट, सो दिस इज योर सीएनएफ बाय यूजिंग ट्रूथ टेबल मेथड. ओके, नाउ we will find out one more example. Find the CNF and DNF of the same statement by using truth table method. Okay, so by using truth table, we will calculate here CNF and DNF. P calculate CNF and DNF with truth table method. I think this is the very simple method, and आप यहाँ पे गलती कर ही नहीं सकते हो. Maybe in statements form there is a small mistake, but यहाँ पे गलती हो ही नहीं सकती अगर आपको truth values लिखना आता है correctly तो, right? So यहाँ पे statement दिया हुआ है first. P double implies Q. P double implies Q or R implies negation of P. Okay, P double implies Q or R implies negation of P. So here P double implies Q or R, negation of P. So first of all, find out the truth table. So we required P, Q, R. Okay, so P, Q, R, then Q or R, right? Here Q or R, then P double implies Q or R, negation of P, then P double implies Q or R implies negation of P, right? A के एग्जाम्पल में CNF DNF निकालेंगे. T T T T F F F F T T F F T T F F T F T F T F T T 4 5 6 7 8 T F. Okay. Q or R. So Q or R, T T T F T T T F. P double implies Q or R. If both are true, then only true. True. T T T T T T. Then T F F F T F F T F F T F. If both are false, then also it is true. So F F and T. 1 2 3 4 5 6 7 8 9. So here is T, right? T T F F F F T. Now negation of P. So here is F F F F T T T T, right? So P double implies Q or R, implies negation of P. So T F F. Here is T F F F F F. So here is FFT. You will get here FFT. P double implies Q or R. T. Here is T. So therefore here TF is F. FF T T T T T. Okay. Now if you observe here, first T is here. First T is here. So the write down corresponding values of this PQR. So corresponding values of PQR are TFF. So you will get DNF as here. We can write the DNF. So we can write here DNF as P and negation of Q, P and negation of Q and negation of R. Here we can see the corresponding truth values of, while writing DNF, we can write the truth value. First calculate T. So P, negation of Q, negation of R. Then next T is this. So you will get negation of P, Q, R, right? So or negation of P and Q and R, right? The next T, you will get corresponding values are negation of P, Q, negation of R, right? So or here you will get negation of P and Q and negation of R. or. Next is so here we will get negation of P, negation of Q and R. Negation of P and negation of Q and R. Right? Or last one, there are 5 T's, no? So fifth one, FFF, negation of P and negation of Q and negation of R. This is your DNF, disjunction of fundamental conjunction for the given statement, right? This is your DNF. Now we can write CNF. So for that CNF we will require here F. So see the first corresponding value of F. F is this, right? So here F corresponding values of. Now F. So here is negation of P or negation of Q or negation of R. Negation of P or negation of Q or negation of R. And the next step, negation of P and or negation of Q and R. Negation of P or negation of Q or R. And the next step is negation of P, Q, negation of R. Negation of P or Q or negation of R. So this is your CNF for the given statement. The same CNF and DNF we can calculate with the help of truth table. Okay, I hope getting it clear to you. So it is very difficult to find out CNF and DNF and the statements involving more than 2 statements. So at that time this method is very simplest method to calculate the CNF and DNF with the help of truth table. Okay, I hope you are getting it how to find out the CNF and DNF with the help of truth table. Now next part is logical quantifiers. Okay, so how to write down the statement with the help of logical quantifiers, that we will see. Now suppose consider the given statement. Suppose the statements are given like this: x is greater than 9, first one. Suppose second is x plus y is less than or equal to 8, or we can write suppose x plus y plus z is equal to 9. So these are the sentences but not the statements. As I told you in the previous lecture what you mean by statement and what you mean by sentence. A declarative sentence is known as a statement. It means either it will have a truth value false or true, but not both simultaneously, or it is confirmed. It means either it is true or false. There is no dilemma, but here is dilemma. It means for some values of this x's there are some values, not only single value which gives you this statement is true. So these are the sentences but not a statement. Okay, so these are the sentences but not a statement. So for that, here is 9. So for that, we with the such statement sentences are known as propositional functions or predicates. Okay, such statements are such sentences. Such sentences are known as propositional functions or predicates. Right? Propositional functions or predicate. Such sentences are known as propositional functions or predicates. Right? So this is your logical quantifiers. It means these propositional functions or predicate in one or more variable is a sentence that becomes a propositions. So when the variables are given in definite values, from the set of values it can take, then the values which are variable assumed to contribute the collection called as the universe of discourse. Okay, so these are not the statements, these are the predicates. It means the values of the statements, truth values of the statements is depending upon the values of x and y here. So therefore these are not a statements, these are the predicates. Okay, so for these predicates we will use the quantifiers. Okay, so first is universal quantifier to denote the predicates. Let's see here what you mean by universal quantifiers. So let if p of x is a predicate with the variable x as an argument, the mathematical symbol for the quantifier for all, which is denoted by for all, which is denoted by this symbol for all, right? For all, so that the proposition can be written as for all values of x, p of x, which is interpreted as for all values of x, p of x is true, is a proposition in which the variable x is said to be universally quantified. Okay, the proposition is said to be universally quantified, and for all is known as the universal quantifier. If it is given that the given sentence or proposition is true for all the values of x, then that statement is said to be that proposition is said to be universally quantified, and that quantifier is known as universal quantifier. Okay, now next is existential quantifier. Existential quantifier, it means what? Suppose for the predicate p of x, it means the statements, the sentence is the proposition or the predicate is true for some values of x, not for the all values of x, then that is denoted by with the help of there exist, right? So for suppose the statements for the predicate p of x for all values of x, p of x is false, but there exists at least one value of x for which p of x is true, right? Then we say that x is bounded by the existential quantification. The word there exist is denoted by there exist, and there exists x p of x means there exists a value of x in the universe of discourse for which p of x is true. Okay, so this is known as existential quantifier. Okay, now we will see here determine the validity of the arguments. First, we will see the validation of the argument. So, which are the hypothetical syllogism or law of detachment, law of contraposition that we will see here. So, see, determine the validity of the argument. If the given argument is true or false, right? Or the given argument is valid or invalid, that we will see with the help of sentences. Okay, now what is given? Given S1 is all my friends are musicians. Now see here, all my friends are musicians, and S2 is the statement John is my friends. S3 is the statement none of my neighbors are musicians, and S is the your final assumption that it means with the combining with this statements you will get the final answer John is not my neighbor. So by combining all this, we will check the validity of this statement, whether whether the given statement is valid or invalid. Okay, so for that it is given that let P is equal to, we'll see that let P denote the statement all my friends are musicians. All my friends are musicians. Okay, and Q denote the statement John is my friend. Q denote the statement John is my friend, and R denote the statement my neighbors are musicians. Now see here how I written my neighbors are musicians. Okay, and what is our statement S? So what will it indicate? S1 is a P, because P and S1 both are same. All my friends are musicians, and we denote P is also all my friends are musicians. S2 John is my friend, so S2 is as it is, S2 is equal to Q, And S3 is none of my neighbors are musicians, but I denoted it as my neighbors are musicians. So it means S3 is equal to negation of R, right? S3 is equal to negation of R. Hence we get S1 and S2 and S3, that is P and Q and negation of R is a statement form. Right? This is your statement form. Now, this is, as it is a statement form, we'll check the validity of this. So, conclusion. What is our conclusion here? John is not my neighbor, right? Conclusion is given that John is not my neighbor. Now, we'll consider the two statements small. T1 is John is musician. Suppose John is musician. T2 is the statement, suppose John is my neighbor. Right? John is musician and John is my neighbor. Then form of the premises, what you will get? Q and P implies T1. What is our Q and what is our P? John is my friend and all my friends are musicians. So which implies T1 is John is musician. As John is, all my friends are musicians and John is my friend. So does it imply John is a musician? Yes, John is a musician. So now we can write here now P and Q and the negation of R implies T1 and negation of R is true. John is musician, but what is negation of R? It means S3. What is your S3? S3 is none of my neighbors are musicians, so which is here contradictions. That is John is musician and my neighbors are not musician. Hence मतलब यहाँ पे क्या है कि अगर मेरे neighbors musician है तो John ये मेरा neighbor नहीं है. See, John is my friend and all my friends are musician, which implies John is musician. But now P and Q and negation of R implies T and negation of R. हमारा जो भी conclusion है उसके ऊपर P and Q and negation of R, which implies T and negation of R. It means this statement is true. That is, John is musician and my neighbors are not musician. Hence, John is not my neighbor. Hence, John is not my neighbor, that we want to prove. So, this statement is valid. Therefore, given argument is valid. Given argument is valid argument. Okay. Ultimately, we are getting the same with the help of this. Okay. Now, we'll see the validity of this statement. So, validity of the given statement. Suppose, determine the validity of the argument of the given statement. If S1 I like mathematics, then I will study. S2 either I will study or I will fail. S, if I fail, then I so not like mathematics. Okay, so then I do not like mathematics. Sorry, here I do not like mathematics, right? So if I fail, then I do not like mathematics. Now here, so we'll first of all we write the P. P is our statement. I like mathematics. Let P be our statement here. I like mathematics. Q, I will study. R, I will fail. and S1, P implies Q, right? I like mathematics, then I will study. If I like mathematics, then I will study. S2, I will study or I will fail. So Q or R, right? And what is your conclusion? S. You can write S here. R implies negation of P. If I fail, then I do not like mathematics, right? This is your conclusion. We'll see the validity of this statement. So we can check the validity of the given statement with the help of truth, and R implies negation of P. P implies Q. T, T, F, F, T, 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 T. Q or R. True, true, false, true, 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 false. Negation of P. F, F, true, true, F, F, true, true. Right? R implies negation of P. T, F, 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 T, 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 F, T, 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 F, 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 T, 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 T. Right? Now, here you can see the rows, those in which our premises are true. And the premises are true, but the conclusion is false. Thus, the argument is not valid. Now, see the premises. In this premises, here suppose there is 1, 2, 3, 4, 5, 6, 7, 8. If you observe here in the row 8, in this row, the premises all are false in the 8th row. Right? In the 8th row, the premises are false, but the here conclusion is true, right? Right? Here conclusion in the first row also. Okay, in this first row, all the premises are true, but the conclusion is false, which is not valid. Right? So in this argument, all the premises in the first row only, the conclusion is true. The premises are premises are true, but conclusion, see here I'm marking with this pen. In this row, premises are true, but conclusion is false. Therefore, this is not valid argument. Not valid. This is not valid argument. Okay, because premises are true and conclusion is false. All the premises are true and conclusion is false, which is invalid argument. Okay. Now we see the quantifiers here. For over the universe of a book defined, propositions b of x is equal to x has the blue color. M of x, x is a maths book. I of x, x is published in India. Translate the following. First one, for all x, M of x and I of x implies B of x. Very good. All mathematics. So first one, we can write here for all. So all mathematics books published in India have blue cover, right? Very good. So first one, very simple, for all. Here quantifier is denoted by for all. So here we can write all mathematics books, all mathematics books all mathematics books published in India, published in India have blue color, blue cover, sorry, have blue cover. Okay, second one. Now statement is given. Use the notation. There are maths books published outside India. It means there exist some maths books which are published outside of India, right? So we can, inside of India it is I of x. So outside it means negation of I of x, right? So you will get there exist x, m of x, and negation of I of x. This is your existential quantifier. Can denote with this. Okay. No. Rewrite the following statement using quantifiers, variables and predicate symbols. First one. All birds can fly. So for that we have to write P of x and Q of x. Right. First one. All birds can fly. So P of x, x is a bird. Q of x, x can fly. Okay. Then the statement can be written as, for all x, P of x implies Q of x. It means if x is a bird, then all birds can fly. Right? Second one. What is our second statement? Not all birds can fly. Not all birds can fly. So it means there exist some birds and they cannot fly. Correct? So there exist some birds and they cannot fly. Third one. What is our third one? Some men are genius. So A of x, x is a man. B of x, x is genius. Right? It means there exists some men which are men and genius. Correct? No. Next one. Some numbers are not rationals. Okay. So suppose n of x is a number. X is a number. Q of x. X is rational. Then the statement can be written as, then the statement can be written as, there exist x, A of x and B of x. Oh, sorry. Here the statement can be written as n of x. N is a natural number, no? So then the statement can be written as, there exists x, n of x and negation of q of x. Not a natural number. Okay. This is our fourth one. Fifth statement, which is fifth. There is a student who likes mathematics but not geography. So first one, x, s of x. X is a student. M of x. X likes mathematics. G of x. X likes geography. Okay. Then the statement in a symbolic form, you will get there exists x, s of x and m of x. Means x is a student and who likes mathematics and not like geography. Right? So what is sixth one? Each integer is either even or odd. Okay. So sixth one, I of x. X is an integer. X is an integer. E of x. X is even. O of x. X is odd. Then the statement is in a symbolic form. Then the statement in symbolic form is for all x, I of x implies E of x or O of x. Right? So either it is even or odd. Okay. Okay, we'll take one more example. State whether true or false. So there exists, negate the statement. One more type of question is there. Negate the statement. Negate each of the statement. Okay, so here we will get first statement for all x such that mod x is equal to x. Second one, there exists x, x square is equal to x. Okay. Third one, if there is a riot, if there is a riot, then someone is killed. Then someone is killed. Right? Fourth one, it is daylight. It is daylight, and all the people are arisen. All the people are arisen. Okay, so we'll see solution first. For all x, mod of x is equal to x. It means there exists some x where mod of x is not equal to x. Okay, there exists x where mod of x is not equal to x. Negation of this. Okay, there exists x, mod of x is not equal to x. Now here there exists x, x square is equal to x. So as x square is equal to x, it means the negation of this is there is for all x. X square is not equal to x. For all x, x square is not equal to x. Okay, third one. If there is a riot, then someone is killed. So we have to write down first of all statement. So P, there is a riot. Q, someone is killed. Someone is killed. Okay, so how can write down the first statement? The given statement is, if there is a riot, then someone is killed. Then negation of this. So negation of P implies Q is equal to negation of P or Q, right? So which is equal to negation of P. So it is P and negation of Q. It means there is a riot and someone is not killed. There is a riot and someone is not killed, right? This is your negation of the statements. Okay, so determine the next type of question where existential quantifier. Okay, here determine the truth value of, determine truth value of determine truth value of each of the following statement and negate every statement First one, there exists x plus 2 is equal to x. And second, for all x plus 1 is greater than x. Truth value, there exists x plus x. So first statement is, there exists x plus 2 is equal to x, right? So this is false statement. Will not get the value of x where x plus 2 is equal to x. Okay, now negation of this statement. So negation of there exists is false for all, right? So negation of this statement is, for all x plus 2 is not equal to x. Yeah. Now second statement, you can see the second one. For all x plus 1 is greater than x. So this is true. This is true statement. So negation of this is what? For all x ka negation, there exists x plus 1 is less than or equal to x. Okay. I hope you are getting it clear how to write down the truth value and negation of the given statements. Okay, so this completes your existential quantifier, logical quantifiers, and validity of the argument, and then universal quantifier, normal form, using truth table, without using truth table. Okay, everything we covered here with the conjunctive normal form, disjunctive normal form, every part is covered here. I will be here at the same time tomorrow, 11:15. Okay, exactly 11:15 a.m. with the new topic of discrete mathematics, that is mathematical induction. If you are liking my videos, please do like, share and subscribe.